Okay, so very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department from IIT Kharagpur, and I'll be taking your live interactive session for the course Computer Vision. This course is taught by Professor Jayant Mukhopadhyay from IIT Kharagpur. And what we'll be doing, we'll be solving some of the multiple choice questions based on the previous week's content. Okay, I'll be solving some of the questions based on the previous week's content in front of you all. Okay. And what you have to do, you just have to try to take a notebook, pen, and paper. Okay. Take a pen and paper and try to jot down all the questions. What are the different aspects which have been given, provided in the problem, and how in particularly you can deal with those particular concepts. Okay. So this is the prerequisite. You just have to sit with a pen and paper, try to jot down each and everything. Okay, whichever in whatever manner I have solved the particular question, try to jot it down. Okay, and after the session is over, please take the PDF of this particular entire session. Okay, and then you try to solve on only yourself. Okay, try to revisit, try to solve this particular question, these particular questions. Okay, and this is how it will be a good practice for you all. Okay, so that is the prerequisite for this particular session. And one more thing, feel free to contact. Okay, I have also provided my mail ID to a lot of students. Okay, feel free to contact in case you are having any doubt in your assignments or in your practical aspects of the course which I have already taught you, and I will be teaching in the upcoming sessions also, as well as in the present session also. We will be looking some of the basic principal aspects as well as some of the advanced concepts, how this particular concept of stereo vision is dealt in real time. Okay, that is how the session will go on. Okay, just 1 second. Yeah, yeah, let us proceed. Okay, let us proceed forward. First question is, compute the essential matrix E provided calibration matrices of two cameras in stereo setup as K. K as a matrix has been provided to us. Okay, K dash as a matrix has been provided to us, along with what is the fundamental matrix F that has been provided to us. And now what we are being asked to calculate this particular essential matrix E. Okay, so options already have been given. In my week 3, I told you a particular short trick. If you have to solve it with the options, you can apply that. Otherwise, let us solve it in great detail. Okay. Now you try to see essential matrix is given by K dash transpose F K. These all the products are immediate multiplication products. Okay. This you try to see. Now, first of all, we'll compute this particular product F into K. Okay. F as a matrix has been given to us. K as a matrix has been provided to us. Now you try to compute the matrix M equal to F into K, that is particularly entry wise. Okay. Matrix multiplication, you already know that it is carried out by multiplying rows with columns. Okay. So, and already the basic you know that if a matrix uh, is of order A cross B and another matrix is of order P cross Q, okay, then the necessary condition for matrix multiplication to happen is B should be equal to P. Then only in that particular case, if B is equal to P, then the matrix multiplication is possible. Okay. This prerequisite already you know, then you just have to carry out the matrix multiplication row by column. Okay. So that you try to multiply, calculate every element. Okay. And then you try to jot down what is the is form of essential matrix, which is k dash t multiplied by m. Okay, this right hand side expression f into k we have reduced to the value which is m. Okay, so now you try to see k dash already as a matrix has been given to us. K dash transpose we will try to calculate. Okay, if you try to calculate the transpose, okay, you just have to interchange the row and column, and now again you have to do the matrix multiplication, which is k dash transpose multiplied by m. Okay, m is a matrix already given to you. Okay, try to multiply the rows with the columns. Okay, and then you try to see the final output which you will get as essential matrix E. Okay, and this particular matrix we will be able to achieve each and every element here I have calculated for you. Okay, my sincere advice to you is, if options are given, okay, see in this particular question, if you will see just by looking at the options are very distinct. This particular element, this particular element, this particular element, these are very distinct. Okay, so in those particular cases, if you are in a dearth of time, okay, as well as you won't be having much sufficient time, because sometimes we as a student we commit calculation mistakes also. Okay, while solving something we will commit some type of calculation mistake. So for compensating those calculation mistakes, as well as for just uh, saving our time, we just try to calculate. Just one second. Yeah, in those particular cases in which we just try to, for saving our time. Okay, first thing is that we have to save our time. Okay, as well as just not only for saving time, sometimes we are in a dearth of time. Why so? Because we unnecessarily just spend too much time in calculation in other questions. Okay, so if the thing is there, okay, and you are given options in the examination, it is a multiple choice question, you just try to calculate only one or two elements. Okay, so all the elements were distinct. Okay, so directly 31 first element E11, whenever I have calculated of the essential matrix E, I can just mark this particular option and move forward. Okay, so this is my sincere advice to you all. Okay, in examination we have to just focus on getting the correct option. Okay, not just by manipulating things or doing anything like that, but just we have to calculate the we have to jot down the correct option. Okay, we have to just mark the correct option and then leap forward. Okay, this would be our intention. Okay, so now you just try to see. Okay, in vision, the essential matrix is, it's a 3 by 3 matrix. It encapsulates the relative rotation translation between two calibrated cameras. Both the cameras have to be calibrated. Governs the correspondence between a point in one image and its epipolar line in the another image. Okay, from your geometry to algebra, suppose you are having two intrinsic calibration matrices k k dash, relative position of b a rotation r, which belongs to the relation SO3. Okay, and translation vector is t, which belongs to relation rq. Okay, then a 3D point projects from homogeneous image points in the first image and x dash in the second, and your epipolar constraint for the projected corresponding image points, which would be projected from x to x dash, would be x dash transpose ex equal to 0. This relationship must hold, and E is the essential matrix. Okay, by definition. Okay, you have to define the normalized coordinates. Okay, x, you already know, x dash you try to calculate. Okay, essential matrix E is nothing but transpose matrix. Okay, Tx R. Okay, Tx is not the transpose matrix, it's the 3 by 3 skew symmetric matrix. Okay, and already in the previous session, when a matrix is given, then how you can calculate the skew symmetric matrix I already told you. Okay, Essential condition is this one. If you remember the formula in the examination, you will not face any problem. Go to my week 4 lectures. Okay, there I have shared the formula. No problem. Even if you forget the formula, there is no particularly issue. Okay, just you have to remember that the condition A into A transpose equal to 0 should hold. That is how you have to formulate that particular skew symmetric matrix. Okay. Then your relationship to the fundamental matrix, if you work instead in pixel coordinates x dash, your corresponding constant is x dash transpose fx equal to 0. F is here is the fundamental matrix. Okay. Two are related by this particular relationship, and conversely the relationship you will be able to obtain, which is essential matrix E equal to k dash transpose fk. Okay. Here you try to see what are the key properties of E. E holds rank 2. Okay. And its other two singular values are equal. Okay. Consequence of its construction is skew-symmetric matrix T multiplied by R. Okay. And the null spaces of E and E transpose give the two epipoles the image of one camera center in the other image. These are the three key properties which will always hold. Okay. Why it is mattering? Okay, this is particularly very important. From past 3 weeks I had been telling you that it is used for triangulation, it is used for pose estimation. How this particular concept is dealt, that I'll show you practically in today's particular session. Okay, you just try to stay with me. Okay, I'll tell you how this particular concept is dealt and are the practical implications. Okay, so triangulation knowing E or the essential matrix E lets you enforce the epipolar constant when finding the correspondences. Okay, which in turn makes the 3D reconstruction or the triangulation well posed. Okay. For your pose estimation, from a set of point correspondence, you can estimate the E, then recover R and T via its SVD, which is the singular value decomposition. Okay. In summary, the essential matrix is the calibration aware version of the fundamental matrix. Directly ties the relative rotation R and translation T of two cameras to the epipolar geometry constant. Okay, which is x dash transpose E x dash equal to 0. Instrumental in the camera motion, 3D reconstruction, okay, 3D scene points. Okay. Moving forward to question number 2, please try to jot it down. Okay, at least try to jot down the homography. Okay, matrix H. Okay, and E dash. I'm just coming in 2 minutes. Okay. Yes. If you will try to see the plane induced homography H of a stereo imaging has been set up. Epipolar has been marked E dash 5 comma 7 in the right image plane, and a point x, okay, which is 3 comma 1 in the left image plane. These both the points are given. Now you have to compute the epipolar line L dash on which the corresponding point of x will lie in the right image plane. Okay, just 1 second. Yes, some issue was there, so I just rejoined. Okay, yes. So you try to see, okay, plane induced homography H has been given of a stereo imaging plane. Epipole E dash has been given 5 comma 7 in the right image plane, point x 3 comma 1 left image plane has been given. You have to compute the epipolar line L dash. Okay, you just have to compute the epipolar line L dash, okay, on which the corresponding point of x will lie in the right image plane. Okay, I hope that you have noted down the homography matrix H. Okay, now we will see things in detail. Okay, if you try to see here, already I have told you this, to find the epipolar line L dash in the right image to the corresponding to the point x equal to 3 comma 1 in the left image, you just have to see the plane induced homography H, okay, and the right image epipole, okay, 5 comma 7. You just have to use the this particular cross product E dash multiplied by H x bar. Okay, x bar you try to see has been given to you, E dash has been given to you. Now you try to apply the homography H into x bar. Okay, just simple matrix multiplication is there, and now you try to match the cross product. Okay, you try to match the cross product. Okay, the L dash is equal to or proportional to E dash multiplied by or cross product of H x bar. Okay, so H x bar directly we have computed. Okay, here we have computed this. Okay, now you just have to perform the cross product. Okay, so when you will perform this particular cross product, then you will get 44 minus 35, 25. Okay, this is the final output. Okay, very simple numerical is there, nothing much complicated is here. Okay, yeah. So directly just have to do this thing, L dash equal to E dash multiplied cross product HX. Okay, these thing, all the things have been provided to you in the question itself, and when you will try to compute, you will easily reach option number B. Okay, be with me. Okay, after completing all the 10 questions today in this session, I'll show you practically how we have come to the practical aspects of stereo vision. I have prepared some of the Google Colab notebooks. I'll demonstrate to you that how these particular concepts are dealt practically. Okay, and from the past particular 3 sessions, we have been dealing, okay, with the concepts of stereo vision, what is epipolar line, how you are doing this, and what is triangulation. Each and everything we'll just try to see. Okay, first let me complete this particular assignment, these particular questions. Okay, after that I'll show you it in great detail. Okay, yes, when a 3D scene contains a dominant plane, okay, relationship corresponding or the plane induced homography you try to see. Okay, theory part I have mentioned here. If all scene points lie on the plane which is pi, okay, then at any point x which is belonging to pi, you try to project the image points x and x dash, satisfying x dash directly proportional to hx, where h is a 3 by 3 matrix. Okay, and you try to scale it up x dash equal to hx. Okay, now in short, if I try to recall what was my epipolar geometry. Okay, uh, even when a homography exists, these particular epipolar constants will still hold. Okay, right image epipole E dash is the projection of the left camera center into the right image. Okay, and given any left image point x, its corresponding right image point x dash must lie on the epipolar line L dash, which is defined by x. Okay, so algebraically you can directly jot it down. L dash would be equal to uh, fx, where f is the fundamental matrix. Okay, yes, and now you have to compute the epipolar line from h and e dash. Then you have to do this particular mapping. Okay, this particular mapping we are just continuing from session number 1 itself. Okay, session one itself. Okay, there I already told you. Now you try to now you try to compute the equation of the line through two homogeneous points a and b. Try to compute this particular cross product. Okay, e dash you try to jot down, then you try to compute h dash h x bar. Okay, then you try to compute this particular cross product, and after all you will get this particular line. Okay, this is the procedure which we just followed, and this was the recap of the epipolar geometry. Okay, very important to theoretically just present, okay, our findings even in our research papers, even in our examinations. It is very important. Okay, and the practical aspects, how we are dealing with these particular concepts, we'll just try to see. Okay, at the end I'll show you everything in great detail. Prepared the codes, ran also, everything is ready. I'll just try to demonstrate. Okay, then you just put all these things together, and then this is the same thing. Okay, same thing I have repeated once. Okay, so you need to explain it once again, but you try to remember. If in the examination it is asked to you that calculate the epipolar line L dash, okay, you just try to compute this particular cross product E dash cross product HX. Okay, try to do this. Okay, then you will be 100% able to do this in the examination itself. Okay, now you try to see this particular question number 3. Consider a stereo imaging setup with two cameras, P equal to left camera, P dash is equal to the right camera. Now you have to compute the fundamental matrix F, which is a very genuine question. Okay, already we have done it. Okay, in past session also in week 4 we have done it, and the same procedure we will be repeating here in this particular question itself. Okay, not much is complication is there. Okay, we'll just try to see. Okay, first of all we have to bifurcate the principal matrix P which have been given to us. Okay, so for the right camera, okay, P dash is the conjunction of capital M and small m, both are the matrices. Okay, to try to bifurcate this particular matrix which has been given to you, okay, for left camera and right camera, and try to separate both of the components. First step is this one. Okay, after this particular thing is dealt, okay, now its center. Okay, you try to do this E dash equal to P dash multiplied by C. Okay, M has been given to us. Okay, now you compute the pseudo inverse of first camera. Okay, pseudo inverse of first camera is nothing but P into P transpose. Okay, it should be equal to the identity matrix. You try to compute this particular inverse, then you have to compute the skew symmetric matrix of the epipole. Okay, in direct formula I have repeated you multiple times. Okay, if a matrix is given, then how to compute its particularly skew symmetric matrix that has been given here. Okay, then you try to put all the things together and try to write down what is F, which is the fundamental matrix. It is nothing but skew symmetric matrix E dash, okay, multiplied by M. Perform this particular matrix multiplication, you will be directly getting this particular option. Okay, same thing is there, nothing new is there. Okay, all the concepts are same. Okay, week 2, week 3, week 4, all the concepts are same. Sit for a while. If you are having any doubt, feel free to ask. Okay, compute all the questions. Okay, thereby in the examination you will feel very confident that I will be able to solve each and every question which will be coming to me. Okay, now if I mathematically try to explain you this particular concept, okay, camera center C is by definition the point in world coordinates that projects to the point at infinity. Okay, algebraically it is the null space of or the kernel of 3 by 4 projection matrix P, PC equal to 0. Okay. First of all, we have to write down the matrix P. Okay. Then you try to solve PC equal to 0. Okay. Everything has been uh, in the same way. If you try to formulate the equations, then two particular conditions will arrive. Okay. Whether W is equal to 0, whether W is not equal to 0. Okay. These two particular conditions will be there. Okay. And then at the end, you will get the conclusion that the camera center is at which particular coordinate. Okay. Now, why this particular camera center is very, very important to us, that we will just see. Okay. Please bear with me. Because if an is given to us, and if you want to do some analysis, if you want to perform some of the basic fundamental aspects, okay, corrections, as well as find out the 3D point cloud, as well as other points, okay, other things if you want to see, then the particular concept is very, very useful. Okay. Then coming to our fourth question, consider the following fundamental matrix stereo setup. F has been given to you. You just have to compute the right epipole E dash. Very, very simple question. This one is okay. Already everything has been mentioned here. Okay. F into E dash should be equal to 0. So by now you must be very efficient in this particular calculation. Okay. Correct option will be A. Okay. How? First of all, we have to seek the non-trivial solution. Okay. Non-trivial solution, nothing new. Okay. F into E dash has been given to you, okay, equal to 0. Okay, well, already you from the theory itself you know that this particular equation hold. You try to write down E dash as E1, E2, E3, okay, matrix, okay, and then F into E dash equal to 0. Okay, this will give you a system of equations. Okay, system of equations meaning is this. Okay, three particular equations are there, but since the right hand side is 0, okay, if a value is given, then very easily from three equations and three variables, okay, these all the variables value can be calculated very easily. But here the right hand side of all the equations is 0, hence the calculation is difficult. Okay. From first equation you get E1 equal to E3. From second equation you get E2 equal to 2 twice of E3. Okay. And from your third equation 2E1 equal to E2. Okay. If you try to substitute the value of E1, you will get same thing, and so all the equations are consistent. Okay. The null space is a all scalar multiples of E1, E2, E3. Okay. So if you try to put one value, okay, by default, if you try to put just one value, single value, okay, just 1 second. Yes, yes, my dear guys. If you try to just see here, jot down just one value, okay, putting just one single value, which is either E3, which is either E2, okay, or E1, okay, scaling up, if you get E3 equal to 1, okay, then you will get this particular E dash as 1 comma 2 comma 1 transpose. Okay, if I am writing in this part formal manner, okay, which is choice number A. In this type of particular questions, particularly when it comes to gate examination, and if a if a question from computer vision comes, okay, then from all the options there is a particular trick is there. You, if after calculating all the equations, you don't have to substitute any value as 1 or 2 or 3, just have to match the ratios. Okay, from first equation itself E1 should be equal to E3. Okay, which is possible in question number, in option number 1, in option number 2, as well as in option number 3. Okay, good. But the second constraint which is there, okay, Just 1 second. Yeah. The second constant is E2 should be equal to twice of E3. Okay. So this particular thing you are able to hold in option number 1 only. Okay. So option number 2 will get automatically eliminated. Okay. So going through the ratios also can you would be able to solve. Okay. Now two things I have solved. Okay. 2E1 should be equal to E2. Okay. 2E1 should be equal to E2, and this particular thing is also there in option number C. Okay. So option number C can also be a principal solution. Okay. If we substitute E3 as 2. Okay. So it's a MCQ, but mistake is there from my side. Okay. Both the options would be correct. Okay. Since we are going by the by the fundamental equation f into e dash equal to 0. Okay. First, option number B is not satisfying any of the constants. Okay, but those two particular A and C option are satisfying both the all three constants. Okay, which are E1 should be equal to E3. Yes, E1 is equal to E3 in option number A and option number C. Okay, E2 should be equal to twice of E3. Okay, which is there in your option number B, option number A and C. Okay, and twice E1 should be equal to E2, which is also there in option number C. Hence, both the options would be correct. Be very careful in the examination. Okay, regarding these type of questions. Okay, just 1 second. Yeah, be very careful in these type of questions in the examination. Okay, which option you have to pick and which option you have to eliminate. Okay, moving forward to this particular question number 5. Compute a homography induced by plane at infinity h infinity for camera matrices P and P dash. Both the matrices have been given to us. Okay, P and P dash. Now, for calculating the fundamental homography matrix H infinity, we have to use the notation M dash multiplied by M inverse. Okay, M has been given to us. No, M, you try to just notation changes there. Nothing new is there. Okay, P and P dash I have uh, just for the sake of separation only. Okay, separation only I have written M and M dash. Okay, so M and M dash try to separate. Okay, then you try to take the determinant of M. Okay, okay, you try to take the determinant M. Okay, after calculation of the determinant, you have to compute all the cofactors because we have to calculate the inverse. Okay, cofactors you try to calculate, then you have to calculate the adjoint. Okay, which is cofactor table transpose. Okay, this you try to compute. After that, M inverse is nothing but one point determinant of M multiplied by adjoint of M. These both the notations you try to keep. Then you try to multiply M dash into M inverse. Okay. So H infinity would be nothing but M dash into M inverse. Okay. That H infinity you just try to see here. It is coming like likewise this particular value. Okay. In this type of questions, you need a very good practice. Okay, of all these steps, there is nothing shortcut is there. Okay, which I can provide to you. Shortcut is there. Okay, but I have already told you. Okay, you can take it, but it will take more time. So fundamentally you try to go. If anything new comes to my mind, I'll share with you. Okay, but the matrix inverse calculation in the examination you would be able to do only if you are well versed with it. Okay, nothing to worry about. Take a pen paper, note down what is the matrix M. Okay, what is how we can compute the operation M inverse. Okay, first we have to take the determinant, then we have to compute all the cofactors, then we have to take the adjoint of M, which is a cofactor table transpose. Okay, then you have to invert the M. Okay, inversion means nothing but 1 upon determinant of M multiplied by adjoint of M. Then you try to multiply M dash multiplied by M inverse. Okay, and try to compute the matrix H infinity. Okay, this all the operations you would be able to do if you are well versed with the theory part and you have solved multiple questions. So after the examination is over, sincere advice, take the PDF, try to jot down all the questions, try to principally solve them. If any doubt is there, feel free to ask in the upcoming session. Okay. Yeah. Now, when we talk about homography induced by a plane at infinity, we are tapping a deep connection between the projective geometry and we are trying to see how the cameras behave in the real world. Okay. Plane at infinity in projective space, you try to see in projective 3D space governed by relation P3. Okay. Augment the ordinary Euclidean points x, y, z. Okay, with a fourth homogeneous coordinate w. This we are doing from session number 1 itself. Then we are saying that all points which belong to w not equal to 0 represent the finite points. The plane at infinity, pi at infinity consists of all the points. These don't correspond to any finite location. Very, very important when you look at parallel lines in the world. In a perspective image, they appear to converge to a vanishing point. Okay, this vanishing point is the image of one of the infinite directions. Okay, so camera projection and the planar homographies P for the image has been given to you, then X another image has been given to you, and as a special case, if the plane is at infinity, then you try to see H infinity is nothing but M dash into M inverse. This particular relation directly we have used. Okay, M dash given to us, M inverse we have computed, multiplied both the matrices and got the answer. Okay, this one we are doing from week number 1 itself. Okay, that is why I am not doing not repeating the things itself. Okay, rather than I'll focus on the new things. Okay, which will appear. Why this particular thing is mattering? Because for stereo rectification, what is stereo rectification? Okay, sometimes in camera calibration, okay, some of the parameters have to be adjusted such that both the cameras are focused on same image. Okay, that is your stereo rectification. When you want to wrap each image, okay, so that the corresponding epipolar lines become horizontal scale lines, okay, then you have to use this particular concept, okay, of homography at infinity. Okay, just recap this particular formula, and if you want to see this particular concept in detail, feel free to go through the video lectures. Okay, there it has been explained by making a plane, okay, and solving all the principal equations from where this particular relation has come. Okay, as well as you can use this PDF also. Okay, feel free to use the resources for your own benefit. Now, question number 6 or the next question. Harris measure is invariant to 2D rotation. Okay, is it a true statement? Is it a false statement? Okay, feel free to answer it. Okay, in the chat box, because it's either it can be true, either it can be false. Okay, these all are the type of questions which can be asked in the examination. Feel free to answer. Okay, you might not be correct. Okay, but if you have gone through the lectures, there it has been beautifully explained. Okay, try to respond whether this particular statement is true or not. Harris measure is invariant to 2D rotation, okay, or not. True or false? I'm not giving any hint. Feel free to answer. There, then after I'll discuss. Takes 2 minutes time. Try to think, then try to answer. try to answer. Even though you are not correct, no problem. But at least I'll have an idea where to explain, what to explain, whether to dive into deep. Just type in the option either it is true or false. Okay, no problem. It's a true statement. Okay. The key reason why the Harris response is invariant to any image plane or rotation is that it depends only on the eigenvalues. Okay. The local autocorrelation matrix and eigenvalues they won't be changing. If you rotate the coordinate axis, still they won't be changing. Okay. At each image point x comma y, you have to compute the weighted sums of squared gradients in a small window around it m. Okay, summation of u comma v. Okay, multiplied by w. Ix ix iy, the partial derivatives of the image density intensity x and y. W u comma v is a smooth window weighting. Okay, w function in terms of u comma v. Okay. And Harris response from these eigenvalues, let the two eigenvalues of m be lambda 1 and lambda 2, then the Harris cornerness measure is typically formulated as r equal to determinant of m minus k whole bracket trace of m whole square. So it will be equal to lambda 1 lambda 2 minus k lambda 1 plus lambda 2 whole square. Okay, for some constant k. Okay. Why rotation doesn't change r? Rotating the image by an angle theta simply rotates the gradient vector at each point by theta. In your metric terms, okay, if you rotate the coordinates by r theta, structure matrix transforms as m transforms to r theta, okay, transpose multiplied by m multiplied by r theta. Okay. Now similarity transforms of a matrix leaves its eigenvalues unchanged. Okay. Hence, the two eigenvalues lambda 1 and lambda 2 are exactly the same before and after the rotation. R is built only from lambda 1 lambda 2. It too is identical under any in-plane rotation. Okay. Okay. So the intuition or the inference which we can just infer is that corners look the same no matter how you turn the page. Okay. If you rotate a checkboard corner, it's still a corner only. Okay. Harris detector, it captures exactly the strength of that two-way intensity change, okay, without ever caring about its absolute orientation. So, hence, indeed, your Harris measure is invariant to your 2D rotation. This statement is particularly true. Okay. Moving forward, okay, suppose the motion of the cameras is a pure translation with no rotation and no change in the your internal parameters. One may assume that the two cameras are P, okay, and P dash. If the camera translation is parallel to the x-axis, then E dash equal to 1 comma 0 comma 0, okay, transpose of that. Now, can you compute the fundamental matrix from the given information? Very interesting. Okay, directly relation you have to use, which is nothing but the q symmetric matrix of E dash which has been given to us. Okay, for pure translation, okay, and no rotation, the uh, identical intrinsics k fundamental matrix f will be nothing but k inverse transpose multiplied by symmetric matrix t multiplied by k inverse. Okay, q symmetric matrix t, if you try to compute very easily, you would be able to do that. Okay, already the relation I have told you. Then it you would be able to match with that particular option. Nothing you have to do, you have to just compute this particular q symmetric matrix. Okay, And the relation already I have showed you in multiple places, but I'll still try to show you once again. Okay, just 1 second. Let me save this for you. Okay, this particular one, just 1 second. In the starting itself, I tried to show which one is the relationship. You can jot it down. Okay, directly. Yeah, this particular one. Okay, if E1, E2, E3 are given, then this particular one is the skew-symmetric matrix. Okay, you try to jot down this particular relationship directly. In case E dash or a coordinate has been given to you, you try to compute the skew-symmetric matrix. Fundamentally, you would be able to do it and you would be able to get to the correct option. Okay, this is the, I think, last session of the stereo vision. Okay, the theory of the stereo vision, and I'll be much happy to complete it with some of the practical aspects. I formulated a Google Colab notebook. Okay, I'll be showing everything stepwise where these particular concepts are dealt. Okay, what are the principal applications which you can see, as well as you can use these in your research also. I'll be sharing the notebooks also. Okay, feel free to contact in case any doubt is there. But just bear with me through all these theoretical aspects. Then at the end, we will go through some of the very practical, interesting aspects. Okay. Yeah. Regarding this particular question, yeah, I think I have explained you. Okay, no problem. Moving forward to question number 8. Consider a stereo setup with P and P dash. Okay. Camera matrices for left and right camera as given below. P has been given to you, P dash has been given to you. If the image coordinates of a 3D point are 4, 6 and 7.33, 6 in left and right cameras, compute its depth, which is the Z coordinate in 3D. That I'll be doing today using coding. Okay, using coding, a particular image is there, then we will try to formulate the 2D point cloud. Okay, 2D point cloud we'll try to formulate and we try to present our results as in heat as a heat map. Okay, okay. So let us first solve it for a single point, then we'll be solving it for multiple points across all the image. Okay, all the pixels of the image. Yeah, you have been given camera matrix P, right camera matrix P dash. Okay, image coordinates are 4, 6 and left camera at uh, where the image coordinates are 4, 6, left camera is 7.33, 6. Okay, in the right camera you need to use the triangulation. Okay, P you try to jot it down, dash you try to jot it down, then you try to segregate. Okay, the segregation already I have explained you. Okay, the after the segregation, for the left camera you will get the matrix K, you will get the matrix T, K dash you will get for right hand camera, and similarly T dash you will get. Okay, this indicates that there is a pure translation along the x-axis by 2 units. Okay, where your focal length would be nothing but 5. Okay, after getting this particular value, okay, left image coordinates have been given to you, right image coordinate have been given to you, then you try to compute the using the triangulation. Okay, after triangulation you can use this all these relationships. Okay, and for the left camera, for the right camera, then fundamentally you can derive after solving for this particular z as an expression will come and you try to solve, then you will get the answer as 3.003. This particular approach you can follow, otherwise you can directly use the relation u minus u dash. Okay, reducing the coordinate points into the homogeneous form. Okay, as I have already done in the previous question. Okay, in similar form and manner you can do that. Okay, then you can use the relation z equal to fx b over d. Okay, fx you know it is 5, b you know it is 2, d is minus 3.33, then you will get minus 3.003. And since it is in front of the camera and you have to use the absolute value which is will come around 3.003. Okay. Yes, so it will match with option number D, and you can verify once again. Also, you can perform these steps. Okay. Otherwise, you can use the relationship which I have just mentioned in the last. Okay. Fundamentally, also you would be able to solve. Otherwise, nothing much to worry here is there. Okay. Shortcut is there mentioned here. Okay. You can use both any of the approaches. Okay. But my sincere advice in the examination, use the shortcut approach only, because for fundamental derivation you require some time. Okay. As well as chances of committing mistakes are also high. Okay, so this is the thing. Then you assume the matrix A has the following. This is question number 9. Assume matrix A has the following single value decomposition. Okay, SVD decomposition. Can A be an essential matrix? This you just have to tell. Either it is yes or no, or a true or false. Okay. Correct option would be no. Why? We'll just try to see. Essential matrix E, which I have been talking about from the first question itself. Okay. It has two very specific algebraic properties. First of all, it is rank 2. Okay. Exactly one singular value is there. Okay. And there are equal non-singular values. Equal non-zero singular values. Okay. Why rank 2 with one zero singular value? You just try to perform the construction equal to q symmetric matrix T multiplied by R. Okay, where R belongs, R is simple rotation. T is the skew symmetric matrix of rank 2. Okay, non two non-zero singular values are equal. Okay, because since R is orthogonal. Okay, for some u comma v and some scalar s which is greater than 0, the essential any essential matrix must have singular values a comma 0. Okay, this is the fundamental aspect. The matrix which has been given to us is this particular one. So the non-zero singular values of a have are these particular one 2 root 2 and root 2, and the third value is sigma 3, which is equal to 0. Essentially, since these two particular values are not equal, hence the matrix would not be an essential matrix. Any essential matrix you can just try to see from question number 1 itself. Okay, it would be the diagonal elements would be of the form a comma a comma 0. Okay, one condition it is holding, that the last element is equal to 0, but rest of the conditions it is not holding. Okay, hence it won't be a correct option. Okay, it won't be an essential matrix. Okay. Next, try to just jot down this particular MCQ. Okay, try to jot it down. It is relating to the same concept. Okay, you just have to compute the uh, depth coordinate, which is the z coordinate. Try to jot down both the matrices P, P dash, F. Everything has been given to you. B, T. Everything has been given to you. Just have to compute the values. Okay. Try to jot it, these matrices down. Okay. Then we will see. use the same relationship as it was there in the previous question, then we will see. Okay. Yes. A stereo camera setup is there with the camera matrices. P is given to us, P dash has been given to us, F is 800, B is 1, T is 0 0.1 meters, which is the translation along the x-axis. Suppose a 3D point X is there, X comma Z, Y comma Z comma 1. Okay, transpose is projected onto the image planes of both the cameras, resulting in 2D image points. Left image X is 160, right image X dash is 120. Then what is the depth coordinate of the 3D point in real world unit? Okay, depth or the Z coordinate, this we have to just check. Okay, so it will come exactly as 2 meters. Okay, disparity D, which you have to compute, which is X minus X dash, which is nothing but 160 minus 120, it is 40 pixels. And then you have to use the depth formula, which is FBT divided by D. F into B will be 800 multiplied by 0 0.1 divided by 40. It will be coming around 2 meters. Okay. So final answer is 2 meters. Okay. This you will get. Moving forward to the next question. If you are given a set of 8 matching point pairs, okay, in two images in pixels, image 1 is given, image 2 is given, and you have to estimate the fundamental matrix F using the normalized 8-point algorithm. Then after applying the algorithm, the computed matrix F has been given to you. Then four particular statements are there. Matrix F satisfies the epipolar constraint for each point pair. Matrix is of rank 2 as required for valid fundamental matrix. The epipole in the right image is given by null space of F transpose. The epipolar lines for the given points in image 2 are given by L equal to F transpose X dash. Okay. So yes, all these statements are true. Why so? Because epipolar constant for each corresponding point X and X dash, these epipolar constraints should satisfy the fundamental equation X dash transpose Fx approximately 0. After computing F using your 8-point algorithm, the matrix satisfies the constant approximately, which is acceptable in practice, hence the statement is true. Rank of F. Yes, the fundamental matrix must be of rank 2. Okay, this is ensured by in the algorithm by forcing the smallest singular value of F to 0. So you have to check via the SVD, singular value decomposition, U summation V transpose. Okay. Summation of all the elements, diagonal elements should be S1 plus S2. Yeah, rank is 2. Okay, rank of the matrix should be equal to 2. Okay. Means the diagonal element should be S1, S2 and 0. Okay. Then epipole from F transpose. The epipole in the image 2 lies in the null space of F transpose. F transpose E dash equal to 0. Hence E dash belongs to the null space of F transpose. Hence the statement is true. The epipolar lines in image 1 given point X dash in image 2, the corresponding line in image 1 is L equal to F transpose X dash. Okay. Fx gives a line in image 2. F transpose X dash gives a line in image 1. Okay. So hence this particular statement is also true. So all statements are true. Hence the answer would be all of the statements are correct. It was a MSQ. This one was MCQ. Okay. And this marks the end of all the 11 questions which I wanted to discuss. Okay. Let me unshare. Okay. Now I'll just try to discuss some of the very interesting practical aspects of your course, which was there in your session number 1, session number 2, session number 3. We were trying to build up the theory, okay, for your stereo vision. Now we shall discuss some of the very fundamental concepts of stereo vision in great detail. Okay, some of the principal applications. Please confirm once whether you can see my second screen or not. Are you able to see this particular collab document? Are you able to see? Could you please confirm once?
Yes, sir, we can see.
Okay, okay, fine. Just 1 second. I think you would be able to see this particular screen also. Yeah. Okay. Yes. So if you just see what is the this particular one is the demonstration. First of all, this is the Google Colab. Okay. Just 1 second. Yeah. This particular one is the your Google Colab platform. Okay. For running the Python codes, a lot of platforms are there. Okay. If you want to run on the local system, okay, feel free to contact me. Okay, in case any doubt is there. Okay, these are the principal practical aspects. Okay, so much of it you would be able to learn if you will ask questions. Okay, so anything if it comes to your mind, feel free to ask. Even in theory part also, feel free to discuss anything. But when it comes to practical, be very careful. I'll be repeating I'll be repeating multiple times. Still, if any student is having any doubt that sir how we are able to do this, do that, please feel free to contact me. Okay, or ask me in between. You can unmute, you can ask. Very few students have joined. Okay, this is the thing. Yeah. So for running Python programs, lot of facilities are there nowadays. Okay, one of the facility is you can run locally on run the Python files locally on your system. For that, you have to install the Python particular language you have to install. Then you have to use a particular editor, which might be Visual Code or it might be for different languages, different editors are there. One particular facility is this, another facility is there. You can use any of the online platforms which provide you the hardware as well as the hardware means CPU as well as the GPU. So both the facilities are available here in your Google Colab environment. This is particularly free for approximately 2 to 3 hours of usage. I am having the pro version also because I need to do a lot of computations. Okay. So the pro version or the upgraded version of this particular Google Colab that will allow you to access multiple GPUs. Okay. Some of the GPUs are free for limited time, but most of your computations, if you are doing one or two computations, okay, they would be, it is more than sufficient to perform these computations. Okay, this is the introduction of Google Colab platform. Okay, how to access this? Very interesting. Okay, here just type it down. Okay, Google Colab, and then go to this particular link, Google Colab notebook, then open Colab. Okay, then in your open collab you just have to perform this particular operation, new notebook. Okay, after new notebook this type of interface will appear to you. Okay, where you can write down the code using this particular plus code. You have to press this, certain lines will be created inside that you can write down the code. Okay, This is regarding how you can create a notebook in Google Colab, okay, as well as how you can write down the particular codes, okay. Right. So if I try to show you how to run a particular simple command, okay, first of all I'll press this, okay, then if I write down, okay, this is a simple statement in Python, okay. If you try to run it down, okay, first of all the thing is you have to check the runtime. If runtime is checked here, then there is a facility here, you can manage your sessions. If you are having multiple notebooks, you can do that. Other facilities there, you can change the runtime time, okay. When you are using the you are performing some deep learning calculations, okay, your data set is large, okay, large data set, what do you mean by that? Like greater than 1 GB suppose, okay, or the image files are there, or some deep learning computations are there, or it, you know, some model training is there. And you already know that it will take a lot of your time. So in order to save your time, you can use the GPU also, okay. Here this particular facility is there. Either you can use Python 3, even you can write code in R. R is also a software. It is basically, it will basically run on C language, okay. C, C sharp, or C plus plus, whatever. If you are well versed with it, you can write it down in R environment also. Well, Julia is very new, okay. After Python was launched, this particular language, this particular environment was created, okay. So by default, it is Python 3, because most of our deep learning projects, as well as as well as our projects in day to day of our jobs, is regarding Python 3 only. Okay. It is there in this particular environment only. Now, hardware accelerator, what do you mean by this? A lot of things have been shared with you. What particular GPUs are available, how long you can run. Okay, it is showing you that for at most 12 hours. But in reality, when you will be training models, it won't be running more than 3 hours. Okay, at max, after 2-3 years of usage of this particular platform, I can say it ran for 3.5 hours for model training. Okay. So particular facility is there that you can use either CPU. CPU means nothing with no hardware accelerator. Simple plain machine will be allotted. It is a virtual machine. Okay. Virtual machine, I should explain you, because I'm a good person to explain you this. Okay. Suppose you are seeing me. Okay. Through this particular laptop, I am having a laptop. It is having a CPU. It is having a GPU, and I want to share the same laptop with you. Okay. So in this particular case, we use the concept of virtual machine. A lot of virtual machine softwares are open source softwares are there. For example, AnyDesk is there. Okay. So if you install AnyDesk on your PC, if you install AnyDesk on my PC, then you would be able to have a remote access of that particular PC at your end, okay. So this is the particular concept of virtual machine. So similar to that, Google Colab uh, has purchased a lot of CPUs, has purchased a lot of GPUs. Then through your networking, they have connected all these CPUs and GPUs, and they are providing you access to the CPUs as well as the GPUs. Okay. So this particular one is the fundamental concept. Okay, CPU means no hardware acceleration. Okay, no GPU would be there. Graphic processing unit, which will make the computation faster. Okay, particularly in case of deep learning data. Okay, by default is CPU. Okay, you can change it for GPU. You can change it for TPU also. My sincere advice to you is that if you are beginner, okay, and you see all the libraries. For example, here I'll be using OpenCV. Okay, this is more compatible with your T4 GPU. Okay, not with this V28 TPU, because there are a lot of errors would be there, which will take much of your time. Okay, to solve. So, like based on experiential learning, I'm telling you, you go for T4 GPU. There, much of the constraints are solved. Okay, regarding your deep learning projects. Okay, but V28 GPU, this particular TPU is much faster. Okay, you can have an access of it, but practically after half an hour also sometimes it gets disconnected. Okay, so this particular experience I am sharing because some of the students would be very much interested in some research, in some projects, in some internships. So for them, this particular experience is critical. Okay, so here you can change the runtime tab, then you can save. Now since I have written this particular code, okay, runtime you can see here, okay, it is connected. Why? Just second, just 1 second. Yeah, when I connected this particular runtime from this particular option runtime, I went to change runtime type. Okay, then I saved it. Okay, this particular runtime automatically got allotted to me when I tried to run this particular line. Okay, so what resources through virtual machine has been allocated to me? System RAM of 12.7 GB and the disk space of 107.7 GB has been allotted to me. After this particular session is over, this whole thing will get deleted. So before it gets deleted, I have to save all my findings, okay, into my local PC. This is very, very essential. If in code itself you are writing a line that your entire thing after running is just saved into Google Drive or it is downloaded locally, then only in those particular cases your files will get saved with you. Otherwise, my dear, in all of the quizzes after the runtime is disconnected, your progress is lost. Okay, try to remember this because in beginning some mistakes happen. Okay, so at the end you try to either download it if you are having time. Okay, I'll just demonstrate how to download all the things, all the files. Okay, but if it is not possible, then my dear students, you can always go at the end, type a line, simple line that direct to this CD, use the CD command and direct towards the Google Drive. Okay. So direct progress of your model or your pickle file or your any model saved file or model file, you can save it in your Google Drive. Okay. So this was regarding basic introduction. Okay, now I'll try to demonstrate. Here I just wrote a line, print hello. If you are versed in Python, this is the first statement which in any language is taught to you. Okay, so it ran perfectly fine, means runtime is connected, RAM is available to us, disk is available to us, everything is available to us. Okay. Now, first of all, for performing the computation or the stereo vision will give you the depth map at the end of the code or two particular codes I'll try to demonstrate. You will always get a depth map. Stereo vision, the principal job was just to calculate the depth. Okay, if you will capture my this particular image, okay, if you capture this particular image which I am projecting in front of you, okay, my image, don't talk about just the screen, and you want to know that what is the distance between my face and my camera, then this is our principal aspect which is dealt between by stereo vision. And what are the principal applications? Principal applications are autonomous driving. Okay, autonomous driving, autonomous docking, pose estimation, triangulation, segmentation, everything the basic arises from here only. Okay. So the library which is there in front of us is this particular one. Okay. Here I have tried to install it. Pip install. Okay. OpenCV Python. First of all, I'll do this. Okay. If Colab is having it, it will say it requirement already specified because a lot of files are automatically downloaded. Okay, automatically downloaded into the disk. Okay, when my disk is loaded. Okay, then you try to import the necessary libraries. Import CV2. CV2 is another library which is there in this OpenCV Python package. Okay, then import numpy as np or matplotlib dot pyplot as plt. These all are libraries, and from libraries I am importing the functions. Okay, you can write down np also, you can write down p also, whichever thing you want to write down. You can import the particular function as any other attribute also, but remember you have to call that particular function through that name only. Okay. So second step I'll try to perform. Okay. Performed in just single go. Okay. Then some theory part already I have given here also. Okay. Then what I am doing here, we are generating synthetic stereo image pairs. Means two images should be there from two different cameras that we are trying to generate synthetically. Okay. How this particular thing I am able to do, you just try to see in this particular code. Height width already defined. Okay. Then uh, create the background. I have created the background images. Then I have created some of the random objects, object 1, 2, 3, 4, and then I am displaying as a left image, as a right image, and I am providing the captions also. Okay, so this left image, this right image, this all, both the things I have provided here. Okay. Now you try to see I have done one another aspect which is computing the disparity map. Okay, disparity map will show me the pixel difference, okay, for each point. Brighter pixels will indicate the large disparity as well as the grayscale as well as the dull pixels. Okay, they will ensure that the disparity is low. Okay, disparity map. Disparity means nothing which we were just trying to compute in the theory as d minus d dash. Same thing is there. Okay, but I am doing it practically here. This is the thing. So first of all, I have to convert the entire image to grayscale. Okay, why I am doing it? I can do it in RGB also, but the process will become complicated and the computation will be much large. Okay, so I ran the code till here. I'll just run this particular line also. I explained you how I obtained the left image, how I obtained the right image. Then I am computing the disparity map. How I am doing it? I am defining the grace. First of all, I am converting both the images to grayscale. Okay. Then I am creating a particular object. Then I am computing the disparity. Then I am normalizing. Okay. All the functions are predefined. Okay. This is the particular case. Okay. When it comes to research, predefined predefined functions are of much use. But when you want to create some another thing, okay, in those particular case, first of all, I have to define this particular function stereo bm dot compute. Okay. So before this, I'll try to make a function and I'll try to provide all the equations. Okay. If you will just try to see this particular function, okay, which is there in Python, I'll just copy it from here and try to do some of the research. Okay, what exactly this particular function is, what task is it performing? I try to see here. Then I'll just get, okay, this I have to write Python because in MATLAB also this particular function is there. Okay, so this particular function or this particular method is already defined in your in your OpenCV, and you already imported OpenCV as CV2. Okay, send loading left and right images and this particular function. Okay, function is used to initialize the object, specify the number of disparities and the block size. Okay, so our job here in Python is simpler. Okay, because we already use the predefined functions, but the application part as well as the integration part, okay, that is very essential for us. If we are having any of the doubts inside it, okay, then we have to change the function, or if we are in a position that we want to change some of the attributes. Okay, suppose a particular case is there in which I don't want to use this particular function number of disparities, then I have to redefine this particular function and then I have to change that particular attribute. Okay, so this procedure is a standard is not a standard procedure. Don't limit yourself to this particular procedure. Okay, so always try to, if you want to do some of the fundamental research, then sincere advice to you is that you can use the pre-built functions, you can build some of the confidence, but after that go for defining your own functions. Okay, So coming back to my code, then I have normalized the pixels. Okay, disparity is in 16, so I divided by 16. Normalization just dividing by W. Already teaching you from week number 1 itself. Okay. Then you use the display functions, which is plot.figure. You are trying to plot this particular figure. See how well the disparity map has come. Okay. Original image which I created was this one, and this one is the disparity map. Means disparity in terms of pixels has been calculated, and some of the principal areas already it has marked. Okay, so similarly cmap map I have used matplotlib uh, function I have used. You can use anything. Okay, hot, cool, a lot of attributes are there here. Now after this particular thing is done, I am creating another stereo SGBM object, and then I am computing the disparity, then I am normalizing for visualization, and I am doing another thing. Okay, this thing already I have done previously, but previously the disparity between interpixels I haven't calculated. That I am calculating in this particular step. So interpixel disparity, nothing new. Interpixel disparity is the same d dash. Okay, same d dash which we were computing in question number 10. But this is the practical aspect. Go to the function, try to learn that how this particular disparity is actually defined. Okay, this will be very useful for you. But here I am trying to calculate the interpixel disparity. Okay, now very interesting result you will be able to achieve, that after using, you can use a weighted least square filter or any other filter whichever you like. Normalization filter is there and other filters are there. Okay, so you can use any of the filters. Okay, feel free to use. Okay, then use because a lot of noise is there. See here, no particular data I am able to fetch, so that is why I am using these filters. Then again computing the left and right disparity, then a beautiful thing I am able to obtain is this. Okay, so filter disparity map, then after filter disparity map, okay, disparity I calculated and then I tried to plot it also. Interpixel distance also I tried to plot. After that, if I try to perform the depth estimation, which was the last point. Okay, I assumed focal length as 1. Okay, here I have assumed, but in case of your practical applications, you have to use a function to calculate this focal length and baseline in real time. Then only you would be able to perform this depth estimation in real time. Okay, so thereby here for your sake of clarity or for just for explaining you, I have written this focal length f equal to 1, baseline b equal to 1. I have assumed it, but this is not the end. Okay, sometimes you have to no for practical applications you have to keep on calculating these in real time, like in the research paper which I showed you. Okay, for nanoscience application this particular thing is very useful, stereo vision. But the application part which will be performing is only possible when we are calculating the focal length, okay, in real time. Then the disparity map would be real. How with reference to different reference planes my solid object is behaving. Okay. This is very important. Then depth estimation, computing the focal length. Then I already told you depth equal to focal into baseline divided by disparity. Then I perform the visualization. But after the visualization, I got a very interesting result. The disparity values are all the same and depth values are all the same. Why this has happened? Because this is a synthetic image and it was created on a 2D plane. Hence, the depth is not present. Okay, so conclusion is it is this particular one, that from a synthetic image we have performed the depth estimation. In real world application you have to use the camera calibration. I already told you. Then you have to know the f by v value for absolute depth. Okay, since it was a 2D image which I generated, okay, and placed different types of objects in front of you, so the disparity values will be all same. See here in this particular matrix I am demonstrating here, all the disparities are same. Okay, and depth value would be somewhat norm. somewhat real real value or a known value which will come from Z, because no depth is present. If you are performing this particular analysis, same code, if you will try to run, replace the synthetic image with a real image, then you will get some of the interesting results that I will just demonstrate with another algorithm in few seconds. Okay, just try to go through this particular thing, try to visualize. Okay, take a 2 minute break. A lot I have spoken. Okay, then at the just after this, I'll try to perform a similar type of analysis on a real image. Okay, I am just coming in 2 minutes. Okay, on a real image, when I'll performing this analysis, then you won't be seeing all the disparity values same, because this is not a 2D. This is limited to 3D. Okay, so depth values also would be different. Okay, that we'll just see in coming in 2 minutes. Yes. Now coming towards my second aspect. Okay, first aspect we just have seen the analysis we have performed on a 2D image, 2D data set. Okay, 2D image which we just generated. Okay, this is nothing but a synthetic image. Okay, same concept, same aspect. I'll just demonstrate using this particular notebook. This is a separate notebook. Both the notebooks I'll provide to you. Okay, don't worry much. Okay, try to just run it. Okay, run it once, try to ask the doubts if you are having any, and these all the aspects you can include in your projects. Okay, if you are working on stereo vision or computer vision project. Okay, this is a very hands-on experience for you. Okay, so similar to the previous thing, first of all I have made the setup. Okay, first of all I'll see the runtime. Runtime is CPU. Okay, I'll save it, then runtime here. I'll try to uh, run the first cell. If it is connected, no, it is not connected. I'll try to reconnect. First of all, let me connect to a runtime. Okay. Since two notebooks are there and multiple sessions are not allowed, so I have used two Gmail accounts. Okay. So this is also a hands-on tip for you. If you are using multiple Gmail accounts, you would be able to run multiple notebooks, but don't close the laptop. Okay. If you will close the laptop, everything will be gone. You need an active internet connection as well as keep on scrolling. Yeah. So first of all, I am using the setup, okay, in which I am installing your OpenCV. I am installing your Colab import environment. Okay. Then I am using CV2, NumPy, skimage, then IPy widgets, everything I am using. You may or may not use, but you have to install these particular libraries always. Okay. Then, since the libraries are perfectly installed, it is showing me the versions, line ran correctly. Okay. Now I will get some of the sample stereo pairs. Okay, sample stereo pairs or stereo pairs. These stereo pairs are nothing but the sample images which I have obtained from two particular cameras. If you try to go through this particular image, okay, just I'll press Control and click. Okay, it's nothing but a simple image. Okay, simple image, but it is captured from a camera. Right now you all are having camera, you can use your image, any image you want you can use. Okay, but here for the sake of performing research, I have used two particular images. One is captured from the left camera, another one is captured from a right camera of the same object. You can use your mobile phone, try to capture, try to make a distance, you know, the focal length, everything, you know, try to capture the image of an object from two different planes. Okay, so that image, that exercise I have left, and I have directly imported the left image and the right image. Okay, these images I have imported directly from open source. Yes, yes.
Yeah, in camera or in edit option, there will be option rotation. So if we rotate, that will be work.
Mhm. The rotation is just one second. Yes, the rotation is capturing the same image and providing an angle. So
Mm.
depth values are not changed there. Okay.
Okay.
So if you will try to take an origin, the distance, principal distances from the origin will remain exactly the same. Okay, just by an angle value you are rotating, so it won't be working. You need two different cameras for estimating the depth. Okay,
Okay, understand.
just like our eyes. Okay, we capture both the views differently. There is some distance. Okay, so that is the thing. Distance might be less, distance might be more, accuracy might be less, accuracy might be more, but you need two different images from two different cameras placed at certain angle, and that angle you should be knowing. Okay, from your stereo geometry. Okay, rotation won't work. Okay, that is the thing. Yeah. Now you import these particular libraries, you try to fetch. Okay, this is just for fetching these two particular images. Okay, that I have used, and the images also I have shown to you. Okay, left and right images of a aloe vera plant. Okay, nothing new. Data directory I have just created. Then if it exists, then it is showing yes, it is exists, and it is showing the name. Okay, otherwise it would be showing error. Okay, I will just run to you some sample stereo pairs I have fetched. Nothing new. Okay, you can go through multiple GitHub repos. Okay, they are having all the stereo pairs. Okay, well built in for you. Otherwise it would be much more I would be much more happy if you take two particular webcams or two particular cameras, try to perform this particular exercise, capture different images yourself. Thereby you will learn different types of Python functions also, which are required for capturing images. Okay, and saving the images in two different folders. Okay, left image, right image, okay, of a single object. This exercise you can perform. Okay. Then I have included some of the helper functions, which is I am read gray, means I am converting this particular image to grayscale, then showing side by side, then drawing matches, then drawing epilines. Okay, then normalizing for display. Okay, then I am visualizing here those particular stereo pairs. Okay, so pairs I have tried to visualize. First of all, converted into grayscale. See, the original images are colored. I have converted those to grayscale. Why? So in order to reduce the principal computations, as well as the third dimension RGB, that particular one is eliminated. All the values are from 0 to 255 in a single channel, just to reduce my work. Okay, in real field this particular option won't be available. You have to perform directly on RGB camera. Okay, But just to demonstrate you as well as you to lessen the competition, lessen the time, we do some this type of simple manipulations. Okay, these are the manipulations. Left image I visualized, right image I visualized. Okay, then I have to use some algorithm for your feature detection and mapping. Okay, in this particular demonstration, I have used this particular shift and FLANN. Okay, what is shift? What is FLANN? A brief has been mentioned here. Okay, yeah, shift is scale invariant feature transform. Okay, it was developed in 1999. Okay, it's a notable technique in computer vision where you try to perform some type of feature extraction for the from the image. Okay, converting directly an RGB image to a black and white image is also a feature extraction or a feature transformation. But feature extraction, okay, feature extraction is something else in which you try to draw some boundaries or you try to perform some of the analysis, and on the basis of that you try to extract some of the features. Key point detection is there as well as other things are there. They are only based, okay, on this particular scale invariant feature transform. Okay, you have to perform scaling, you have to perform rotation, you have to adjust for lightning. Okay, these three things you don't have to do. Okay, regardless of this is very very important. For example, if the data set is from a night vision camera, it would be very very different. Okay, data set from a night vision camera would be there, and there you have to formulate or you have to find out where is the target. So this is a particular principle example where we can apply this particular concept. Okay. So shift is scale invariant feature transform. Okay. The details are mentioned here. What are the mathematical aspects and everything has been mentioned here for you in brief. It is able to extract some of the key points or the feature points from a image. So that particular thing I have applied here. The function is directly defined in our CV2 or OpenCV. Okay, predefined library is there, so not much principally I have to perform. Just I have to maintain this thing. Okay, then this particular flan based measure with Lois ratio test. Okay, this particular Lois ratio test is also a very important concept in your computer vision. I don't know whether it would be taught to you or not. If you are very interested, please do Google about it or do some research about it. This is very principally very helpful for us for feature elimination, because a lot of features would be extracted. Okay, in an RGB image, if it is a 3.6 MB image or a 4 MB image, 5 MB, 10 MB image, a lot of features would be there. But Lois test is the particular criteria which allows us to distinguish between two different or three different or multiple different features, and it is often used to scale down or principally reduce the number of features. Okay, this is the Lois ratio test. I'm not delving much into deep, but if you are interested, feel free to just do some research about it. Very easily, you would be able to understand it. Very principal concept in computer science, and I think it is there in your syllabus also. So that thing I have performed. Okay, then I have matched some of the features. Okay, total key points which I have found out is these many numbers. Okay, and the good matches means principally after reduction I have reduced the number of features as 7689. Okay, these are the different features and feature lines are there. Okay, yes, yes,
Yeah, 23,000.
yeah, 23,255.
It will be pixel match.
It is in pixel values. Yes, it is there in pixel values. Okay, these are the total key points which I have identified. After this performing this Lois ratio test, I have reduced the number of features to 7689. Okay.
So, what will be the background mathematical calculation to match?
Mathematical calculation and everything is there inside this particular web page. It is there inside your syllabus also. feel I'll just have some bit amount of patience. It is there, I think, in week 7 and week 8. Okay. How Loeys ratio test is performed, it is very interesting. Just remind me in the next class. I'll explain you mathematically. Okay. It is just like
This kind of mathematics is very advanced level. Can understand.
yes, it is not that much advanced. I'll explain you. You will be able to visualize it also. It is just like your PCA. Okay, principal component
Okay.
analysis is there. Okay, which can reduce 10,000 features to 3 or 4 number of features. So similar to that is there. Okay,
Okay.
okay, that I'll explain you. Okay, in the next session I'll put a PDF for it. Okay, then I'll try to explain you. Put a slide on it. Okay, please remind me about that.
Okay. Sure. Sure.
Yes. So this particular after performing the Loeys ratio test, okay, then I have reduced the number of features and these many number of lines I am able to obtain. What these particular lines are denoting, this is very very important. Okay, both the left and right images I performed sync. Okay, and the in the both the images, okay, if a particular feature or a key point is identified, then I am trying to measure the distance delta. Okay, distance delta in the pixel values, what is the variation, and variation is measured according to this particular function which is defined here. Okay, this particular one, using the Gaussian distribution and using the calculation of the Laplacian transform, we are trying to perform some kind of analysis. Okay, not going much into deep because it will take another session to explain you this. Okay, just remember we are calculating the deformation or the distance delta of those two particular points of the same key point in two particular images that we are trying to perform. Okay, then, after performing this particular analysis, we are performing this epipolar lines. We are drawing the same epipolar lines which were there. Okay, trying to map them, epipolar lines on the left, epipolar lines on the right. Then, since the data set is uncalibrated means camera calibration is not performed. So directly from the inherent features of the image, we try to draw some kind of rectification. We try to transform. We try to perform the horizontal guide. We try to perform rectangular guide. Okay, left rectification, right rectification. We try to perform. Okay. After performing all these things, we are computing again this particular thing, which is disparity. Disparity is the same thing which is calculated in question number 10 as z minus z equal to d minus d dash. Okay. So same mathematical functions are there, which particular block size you want to take. All these things are there. Okay. As well as here from this particular function, you would be able to change the disparity block size. All these particular functions are computed through hyperparameter optimization. Okay, this particular concept is there. Okay, all the calculations, okay, all the variables which I have provided, okay, they have come not just by a simple means guessing. It has not come. It has come from different hyperparameter optimization, and based on the data set, we calculate those particular parameters. Okay, but these are very advanced concepts. So for you, I have performed a simple type of GUI. Here you would be able to change all the different types of aspects. Okay, all the different types of parameter. This is a drag button, and try to see here yourself. This how this performance of our algorithm is changing. Okay, so this one is the normalized disparity map. After that, you try to perform depth analysis and point cloud conversion. Okay, you try to see these type of functions. Okay, after this particular thing, the normalization and scaling, you would be able to achieve the depth map. Explaining you this particular depth map is very simple. The scale already is there in meters. Okay, so I hope that it is not 20 meters, it should be 20 millimeters, but it has come from the algorithm. No need to much define it. That is why calibration is required. Since it is uncalibrated, I can only say that this point is far, this point is below. But if your both the cameras are calibrated, then exact distance up to I think 5 centimeters or even lesser than that, 1 centimeter, half centimeter, we are able to achieve. Okay, through this stereo vision only. But here I would be, since it was an uncalibrated case, I am only able to say that this point, this aloe vera plant is at a relative distance, okay, this particular aloe vera plant is nearer and the background is at a far distance. Okay, this is the only inference which I can make from this particular depth map imaging. Okay, so a lot of mathematical things are there. Okay, this is normalized map. Okay, this has not been scaled. This particular one has been scaled. How I am able to do this, it requires a lot of function. Then I have used this particular computation also, already explained you this. Okay, that particular thing I have done for the entire image, entire pixel. So step number one was your key point detection, feature extraction, then feature minimization using Loeys ratio test. After that, I perform this particular analysis, and after that, I am able to perform this depth estimation. Feel free to explore the entire code and entire functions. It is having a lot of attributes. If I have to explain you all the attributes, please give me some more time. Okay, time is a restraint. That is why I am providing you. And in the next session, if you are having any doubt, feel free to ask me. Okay? Yes.
So one thing I want to know that
Yes.
the pixel matching
Hmm.
and that pixel matching function also apply when we try to identify some
Hmm.
person also. If I upload my picture and try
Hmm.
to identify
Uh-huh.
another image, so
Uh-huh.
that can also apply that function or
Yes, yes. For every type of image manipulation, okay, the function manipulation or any type of function, any type of feature extraction, principal principal aspect is this particular one only. You have to perform the feature mapping only. Okay. After feature mapping, you would be able to say that, sir, from see an image of a size 256 by 256 is very large, so I'm not able to say which features I should take for my analysis. So this particular is the fundamental principle or fundamental thing which you can perform on any type of image analysis. This particular one is the very basic one. And regarding Lewis ratio test, this thing is left. I'll explain you it in great detail in the coming session. Okay, so yes, you can apply that. Okay.
these function also only apply or anything else also can be.
Yes, yes, you can apply any of the function. This particular function is the most advanced one, which nowadays is gaining trend. That is why I have used it. If you have
Okay.
used your this particular Gemini app, Gemini phone, there is a feature which is circle to search. You can encircle anything, okay, in an image, and directly it will search. Okay, so that particular uh, the algorithm, if you want to study in depth, then it is using this shift only. Okay. So
Okay.
so we just try to catch up with whatever things are contemporary. Okay, that is why I have used this particular shift. A lot of algorithms are there. A particular book is means you can find a lot of books on Springer. Okay, which deal with how to extract features, how to do this, how to do that. But since our job is to perform the analysis on the state of art algorithms only. Okay, if you want to start with some kind of computer vision analysis, you can start from ResNet also. But those models already have been used and a lot of work has been already published and people have demonstrated. So that is why we try to refrain ourselves. We try to perform all the analysis on the state of art algorithms which are nowadays trending. Okay, trending is there in your Instagram also, in your YouTube also, in your research also. Okay, so same type
Yeah,
of
definitely.
coherence, same type of coherence we try to perform. Okay, if you are able nowadays to perform some kind of model validation or model manipulation, or rebuild your model from YOLO 12, YOLO 11, it will be a much more contribution to the scientific community. If you will try to modify the fundamental YOLO V1 model, then it won't be a much contribution because a lot of advancements has happened. Okay. So this is how, as a researcher, we have to think. Okay. So that thinking I am sharing from my own experience. Okay. This is the thing. Any other doubts?
No, but
Okay.
lots of code are there. Multiple
Lo-
time I review.
yes, yes.
Review
Multiple
there
revision.
after
Yes. Then only you will
catch
be able to well versed with it. Okay.
catch the point.
Yes. Then only you would be able to say that, sir, this particular parameter, the value won't be 5, it would be 10, 15. So that is the thing. Okay. By practice only it will come. First of all, by practice you have to be well versed with the theoretical aspects. In computer science, a lot of domains are there. If you have chosen the computer vision, then these are the very fundamental basic aspects. Okay. After you are well versed with this only, you would be able to step up in the real field because mathematics is there behind everything. Okay. So fundamental mathematical stronghold you try to make. After that, things are easy. Okay. Okay. That is why I was focusing much on the theoretical aspects. Like in stereo vision, this is there, that is there. Okay. Well, directly I have used a formula here. I showed you. I calculated x, y, z, everything. Those formulas have come from the very basic principal aspects only. Okay. Yes. This is the thing from my side. Okay. Still you are having any doubt, feel free to ask. I'll provide you all of these links. Okay. In the chat box. In the my this particular link which I already shared with you. Okay. 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 The session is over from my side. Okay. Anybody, any student having any doubt, feel free to ask. Otherwise, you can kindly leave. Do join the session next week, same time, same link. Okay. Thank you all for joining the session.
You will share the all the Google Colab in the Google Drive folder.
Yes, yes, I'll just share it after the class. I have pinned a link. Okay.
Okay.
This particular link, there is a particular drive link. Okay. This particular drive link will be having all the notebooks, everything. Okay.
Sure, sir.
Okay. Thank you
Thank you
so
so
much.
much.
Okay. Have a great day. Do join the session next week, same time, same link. Yes, Swati, I'll definitely share the Google Colab notebooks with you. The thing is that you just have to open the Colab and you have to add those notebooks, then only they will open. If you have any doubt, then please ask me in the next session. Otherwise, I'll just demonstrate to you only here only. Okay, just no problem. I'll share my entire screen. Yeah, I think I'm sharing my screen. Okay, see here. Yeah, this is where. Okay, this is Colab. You go to Google Colab. You open Colab. Okay, you can upload a notebook here. Then you have to browse. Then in downloads, if this particular IPyNet file is there, you just have to select it and then you have to open. So I'll provide you these notebooks. Okay, these both the notebooks I'll provide you, but you have to import those in your this notebook environment. Then you will be able to run those, you will be able to manipulate, you would be able to research everything, you would be able to do. Okay, I hope it is clear. Very simple step is there. Okay. Okay.
Okay. Thank you. Bye,
Okay.
sir.
Okay.
Thank
Thank you. Yes, Swati, anything from your side? You want to say anything? Having any doubt? Feel free to ask.
Actually, I was listening your call on number because I am into another call. So I
Okay,
will go
okay.
through your recording and
Okay,
I
okay,
will just
okay.
listen.
Okay, okay,
Thank you.
okay. Okay, okay, okay. No problem. No problem. Okay. Thank you so much for joining the session. Feel free to contact me in case any doubt is there. Okay.
Sorry, just I want to ask something. Is that possible to share the collab notebook?
Yes, yes. I just showed you. Are you able to see my screen once again? Uh, I'm sharing my screen. Are you able to see this screen?
Yeah, yeah, sorry. Meanwhile, I'm in another call.
Okay, okay.
Okay, okay. Ha.
So I'll share the notebooks. You just have to import those notebooks from here. Open Collab, and then you have to upload. Then you have to browse, and then you have to just open this like this. I'll just share the notebooks within this particular folder only. Okay, this particular folder which I have shared with you in the link as a link. Okay, which is having the recordings and everything. Okay, I'll be sharing that. Is it fine? Is it fine?
Yeah, yeah, sure.
Okay, okay, okay. Thank you then. I
Thank you.
am okay. Ending the call. Okay. Thank you.
Bye.
Bye. Have a nice day.
Yeah, you too. Bye.